So what were you saying?
So that's like putting Mentos and Diet Pepsi.
Yeah.
It's the same
Although
thing.
Mentos and Diet Pepsi releases the carbon dioxide in the Pepsi and builds it up really rapidly and can cause an explosion. You can launch little rockets, right?
Is that from the candy itself? Like,
Yeah, there's some catalyst that's in the Mento that,
that just makes them go.
yeah, reacts with the water and the carbon dioxide and releases it in a really rapid thing. But in this case, there's our little guy still going. In this case, you're using much more dangerous chemicals. You're using aluminum as the catalyst and sodium hydroxide, which is NaOH. And the OH has hydrogen. The water, H2O, has hydrogen. That's enough. Thank you. This is going to be really crazy. This is going to go very fast. The water has hydrogen, H2O, as we split when we were doing the car.
Right.
The sodium hydroxide has hydrogen. They both have oxygen in them. That generally can be a bad thing if you mix hydrogen and oxygen, which is what's happening there. It does create energy. There's hydrogen coming back together with oxygen in the fuel cell. When it's not through a measured reaction in a fuel cell, it can be explosive. But the hydrogen is released in a much higher quantity, and the oxygen is generally bound up by the aluminum. Aluminum really loves oxygen. So as soon as the aluminum is exposed, it's going to oxidize, and that's what all this is. All this powder is aluminum oxide. So the aluminum will scavenge the oxygen as fast as it's being produced
Makes that like pasty
and make that
looking
pasty powder kind of thing. And the sodium also
stuff.
will,
Paper towel got burnt.
doesn't it? But that's actually just the crystals of aluminum that
Got
make the
really
black.
hot.
It got really,
Yeah.
really hot. And that's why it's going to, oh, this thing stopped. How long were we going?
I think it just stopped maybe like 10 seconds ago.
And it looks like there's still a little bit of gas in, but the pressure is too low for it to go through the tank. Interesting. Okay, so what time is it now?
140.
So it was about 3 minutes it ran.
Pretty cool.
That's interesting. Okay, so this is going to start a reaction. It is safe, but if you'd rather, I'll do it. Would you rather I did
I'd
it?
rather learn again.
You'd rather learn it. Okay, you keep taping. We have put the lye in here. That is no lie. We have this to go on here. And we're going
Oh,
to
so
use...
that's lye.
That's lye, yeah. Lye is drain opener or sodium hydroxide. It
Is
also...
this thing is liquid lye?
Liquid drainer.
Yeah, my
Just
friend
pour
had
water
that
in
in his house. Yeah, it came with gloves and everything. And
Mm-hmm.
you poured it in the sink, and it literally just like smoke would come out of the drain.
There is no, where's my goggles? There is no danger of putting water in lye,
Right.
but we've got aluminum in here. It's the aluminum and the lye and the water together that have a problem.
That's what causes the chemical
That's what
reaction.
causes the chemical reaction. The aluminum is the catalyst, but it does, unlike most catalysts, usually you say a catalyst doesn't get used up in the reaction. This kind of does because it oxidizes. Now, the aluminum's not gone. You could create aluminum out of this again. You'd have to smelt it.
Right.
Drive off the oxygen. But the nice thing is if you have an emergency like today when it's really, really cold and you're dying and you've got some aluminum foil like you had and you put it in here and then you pour some water in here. Get under here a little better. Okay. You see that immediately you start getting hydrogen bubbling out, and we can show that it's hydrogen.
Oh, shit.
Oh, see that?
And that's the bubbles.
Yep.
Popping.
That's crazy.
Yeah, it's pretty nuts, huh? So what I'm going to do is I'm going to seal this. You'll see the same reaction is happening up here now, like a little candle.
Oh, that's awesome.
I think we put a lot.
Yeah, you did a lot. All right, so then I'm going to take this. I'm going to put this in the sink. Now notice if you touch this, go ahead and very, very carefully put your hand toward it. You're going to have to wash your hands afterward because there's lye on it. But it's getting hot.
Yeah.
That's not nearly as hot as it's going to get. It's going to get hugely, hugely hot. Whoa, whoa, whoa. Okay. So to be extra safe, I'm putting the reaction, letting the hydrogen bubble up and fill this sealed container over water. And that makes it a lot safer because obviously there's water here to put out any particular fire. And if this thing ignited, if this backflashed, then it would at least just pop this out of the bucket.
And then water would just spray everywhere.
Yeah. And what I've done also for safety is I've put brass wool. I've taken brass wool and I've put it inside here as a flashback arrestor so that, see, the flame spreads here, but it doesn't go through.
Mm-hmm.
And it needs a flame temperature to ignite the hydrogen.
Right.
And if it doesn't get through, then theoretically it can't send the thing through to the bucket. And I've also got another piece stuffed there. So I've got two pieces, one in here and one in there. And so one way or another, I'm going to keep that flame from getting through into the whole bucket so that it doesn't go.
Mm-hmm.
And then what I generally do to make it even safer is I just put a towel over the whole thing so that if it exploded and something came off, like a little piece of plastic went off, it wouldn't go whizzing into our face. It would just get caught in the towel. And that makes this a fairly safe procedure. Ooh, now touch it. Oh my gosh. So this is why I'm saying that you could use this to survive in the winter. It's really good. It will not bite.
It'll just explode.
That's hot, right?
Yeah.
1, 1,000, 2, 1,000. I can't hold it for 3, 1,000. We can have a competition so you can hold it longer. 2, 1,000, 3, 1,000. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000. Oh! 1, 1,000, 2, 1,000, 3, 1,000, 4. Henry, give it a try.
He's like, nah.
1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5. Oh no, I can't do it.
It burns the palm.
I know, it does
so
burn the
bad.
palm. We're redoing this.
I fell asleep in my car.
Hopefully not while you were driving. Come and see how long you can hold on to this.
Me?
Yeah.
Oh, okay.
It's really hot.
Is this the hot one again?
This
Yeah.
is the hot one again.
Oh.
1,000, 3, 1,000,
Well, I'm
4,
cold, so-
1,000, 5,
Yeah, she's
1,000,
like-
6, 1,000, 7, 1,000, 8. Really? 9,
She's
1,000.
Oh, she's outside. Okay, I'm done.
Ah. It's like, wait, but you know what? You illustrate exactly what we're trying to
Right.
do with this, as we talked about.
Yeah.
Today's the freezing day.
Yeah, right? Exactly.
You come in here, this is a nice hand warmer, so you don't have to touch the thing. You put your hands just around it.
Oh, yeah, that was nice.
Well,
I'm
okay.
Emily, by the
And you
way.
won't freeze to death.
Oh, Emily, this is Henry.
Hi.
Henry's from Germany. He's 15,
Oh, very cool.
and he's visiting.
Welcome.
It's his first time in the U.S.
Awesome.
So go ahead and warm your hands on it.
Okay.
How cold are your hands?
They're not that bad.
Not that bad.
Oh, this is scary.
5, 1,000. She is really good.
Or
Really?
really cold.
You can hold it that long?
So bad.
I know, it does hurt bad. So we're getting an appreciable amount of hydrogen. The reaction is still occurring because you can actually, when you touch it, feel it blah, 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 blah.
Yeah.
But can you see how, like, if you had this as a heater in your room, in a cold winter thing, then you can obviously make it bigger. I only use, how much aluminum foil? One little sheet of aluminum foil,
Yeah.
right?
And then like a little, like a couple pieces of paper towel.
On the line. The paper towel is not absolutely necessary. The only good thing about the paper towel is that when it's saturated with lye, it makes sure that it touches the aluminum and completes the reaction. This is what we had from last week. See how the aluminum is no longer there? It's just powder.
Oh, yeah.
So it completely oxidized in the reaction. And that's the sort of result. If you're talking about aluminum waste, like all the aluminum cans, you throw these in with some lye and goodbye aluminum can, and then they're very easy to put into compost or into recycling or something, instead of having aluminum cans piling up. In Nepal,
Like soda cans and
Yeah.
stuff. You can get a reaction like that.
oh
from
my
a soda
gosh,
can.
yeah. I guess we should do that next week or next time, just to convince you that this is the solution to creating heat and hydrogen energy and recycle and get rid of the aluminum so it becomes a powder that can be easily transported. And when this happened to me, the idea of doing this was I was in Nepal near Mount Everest Base Camp in a little village, And all the tourists come up to go climbing and trekking, ski trekking lodges. They all bring beer, they bring soda cans, they bring plates of food, they have spaghetti, they got everything. There's aluminum waste everywhere. We were up to our knees in a pit that was as big as half of this room, filled with beer cans and soda cans and dinner plates. There's just garbage in the most beautiful national park in Nepal. I said, wow, I have pictures of this. And I thought, we've got to do something about this aluminum waste because nobody's going to
That
carry
high?
it. Yeah, that high.
Wow.
Aluminum cans that high.
So
as
if
big
you
as
just
half
built
this room.
like a bigger scale of that, you could
Seriously.
put all the cans in and then
And
make
it's-
energy and heat out of
Yeah,
it.
because it's freezing cold up there.
Yeah, that's awesome.
And they're burning, they're cutting down the juniper shrub, which is this endangered species of shrub that takes hundreds and hundreds of years to grow this tall. So when there's a juniper shrub that's this big, it took 1,000 years to get that big. And they just cut it in one day and they burn it to heat up the lodges for the tourists.
Mhm.
So now there's a ban on doing it, but some people still do it. So instead, what do? They bring in kerosene. So you have all these porters carrying bottles of kerosene up to heat, and the smoke is terrible.
Right.
So then they bring up natural gas bottles on yaks, big yak trains carrying them up. They empty them, they got to carry them all the way down.
Mhm.
So we need heat badly up there, we need energy and electricity, and we just showed with this that you can generate electricity from hydrogen through a fuel cell. So the solution seemed to me to be to find a way to make it so that you make that aluminum useful, and then once you've dissolved the aluminum, it's easy to just scatter onto the rocks. Or you could take it down to the city, but nobody's going to carry bags of aluminum cans all the way down 6 days walking downhill to get to an aluminum recycler.
Right.
So this was my solution to that problem. So now we've got this, you hold the lighter from this side,
That's gonna be exciting.
okay? And I will go back here, okay, all right. I'm going to put this over so it doesn't jump if there were a flashback. Yeah, so now you've got a hydrogen flame. Yeah, it's very hot flame temperature. I mean, go ahead, this is safe now, you can see. But that's what hydrogen looks like. When we do methane, you'll find that methane flames are blue,
Wow, that's cool.
which means that methane flames are higher temperature.
And the bucket is.
Right, the bucket's going down because it's using up the hydrogen that we have, so it's going to sink down. And this is not producing it fast enough to replace it. So down it goes and down it goes. But it is a beautiful flame, and you can cook on hydrogen. There are people who do barbecues on hydrogen. You can burn it in the car. There are hydrogen-powered cars that burn hydrogen in a combustion engine. That went out. So hydrogen is a fuel. It's the fuel of the future. We showed the Hindenburg that blew up. It had hydrogen as a lifting gas. But hydrogen is certainly a legitimate fuel. Its safety, there's nothing more coming out of there. I guess maybe if I press down on this.
There you go.
It's a little bit there. It's kind of out now. The safety of hydrogen is the thing that people are always worried about because it's so explosive. So you would not want to have a metal container here. Now the people, wow, is that out? The people in the Boston bombing at the marathon took a pressure cooker and threw aluminum and shrapnel, little nails and stuff, and then they put lye in and they lit it, and boom, it killed people. Obviously, whether it's methane or it's hydrogen or it's gasoline or it's propane, I mean, these things are explosive. This one's particularly explosive. It's so reactive, and yet when it burns, you saw there was no smoke. Do you remember when we were doing the plastic to oil, we went outside and burned that? We had to do it outside because there was so much smoke. There's no smoke. This turns immediately into, when you burn it,
Gas.
hydrogen turns into, when you burn it,
Oxygen.
water. It uses the oxygen of the air.
Oh, and then
becomes
it becomes
H2.